Up next is Max Epelbaum, talking about ETL in Scala.
Thank you. Can everyone hear me okay? Great. Good afternoon. I'm excited to be here today and talk about how I have recently been making use of Scala to handle all of my ETL needs. Quick background on me before I start. I work at Bridgewater Associates. I've been there for about 5 years in a role called investment engineering. So I primarily write code that makes investment decisions, but I'm also responsible for getting all the data I need to make those decisions. And that data just never seems to be in the right place. So I have spent the last year or so building out a framework that I've been using to handle all of my ETL. And so my goals for this talk is for all of you to basically understand the pattern that we came up with. And it's been working pretty well for us since we've started using it. And then also gain some appreciation for the Scala features that made all of this possible without that much code. And then if you're so inclined, at the end of the talk, make sure you're in a position where you could actually go use it for your own needs. Context was, about a year and a half ago or so, I got into a space where I had to get a lot of data into the right place in order to use it. And all the existing solutions for ETL in that space were not great to the tune of lots of SQL and ad hoc C# scripts and things that were just generally not abstracted and not worth building upon. I had some background of existing third-party tools and patterns for ETL, but ultimately those either weren't going to work for me or were too expensive for me to set up internally, and I knew I could get something working pretty quickly with Scala. So I just went down the route of building my own app to do this. I started off with some pretty simple requirements for it. I basically obviously have to connect to wherever my input data is and wherever I have to put it. One of the key important things was we wanted all of our data in our destination to adhere to our internal domain model. So we basically want to make sure once the applications start using this data, it's very clean to pick it up and run with it. You don't have any malformed data or anything you can't make sense of. And then also a big concern was make it possible to test outside of production. So both with in-code unit tests and have integration testing possible so that we could make sure it's all working before we went live with it. And then basically I kind of just kept abstracting this as I went. So I started with one application that just went from one SQL Server database to another SQL Server database. Over the year, that has now expanded to 4 separate applications that all use the framework. And we're connecting, in addition to SQL, to things like we have an internal non-SQL cloud-based data store, S3 buckets, CSV files on network drives, SFTP, REST endpoints. There's really nothing stopping. If it's possible to connect to it in Scala, then people can contribute new adapters to this framework. And so we called this framework tow truck. Name is a bit suiting for towing data around. And so some kind of quick vocabulary before I go into the code for how this works. We have an abstract tow truck app that implements a main method by running a given run mode, where a run mode is a template for specifying what ETL jobs you want to run. And then an ETL job is a singular task that you want to do. And so we have an abstract job trait that has no assumptions about what type of data you're using or what source it's coming from. And then we have what I call job templates, which are a bunch of also abstract extensions of the tow truck job trait that provide enriched interfaces for certain types of data stores. So be it SQL or CSV or S3. And then concrete jobs will extend job templates. So those are kind of the main verbs you'll see throughout this code. So a little clarification on why we went with some of these abstractions. We basically have use cases for having separately deployable ETL applications where at the heart they're all ETL, but they either need to go live in different network drives or be run by different accounts. And so we have that use case. And then within an app, you might have different modes. And so a very common example is we want to run the like full set of all the ETL jobs in the morning, but that takes a while. And then throughout the day, we might want to just pluck the ones that deal with faster moving data and run those. And so basically within an app, you'll have these different modes that you can run. And then a little bit on jobs and the job templates. So basically this tow truck job, again, has no assumptions about what type of data you have, where it's coming from. It separates the extract from the load, so you can run checks in between. And then it also ensures that any failures in any one job won't take down any other ones, so everything is kind of separate and independent by default. And then it's not a very useful trait to extend directly, though, as you'll see when I open up the code. So instead, we come up with these extensions that I'm calling templates, which will enrich the interface, introduce some type safety, and handle a lot of the like data store specific functionality for you. So at this point, most of the active development in this is just in the creation of new concrete jobs following the existing templates. Every once in a while, we'll write a new template, and then spinning off a new app or a run mode is a much more like rare thing. And so I also sent out the link in the Slack general channel, so for anyone who wants to download the code and play around with it, you're free to do so. I'm going to switch to that now and show you how this actually works. So I figured basically I'll start by just explaining what files I have in here. So the 3 files in framework are basically like, those would be the only files you would really need if you wanted to actually go and do this on your own. That's what has the definition of the tow truck app, the tow truck run mode, the tow truck jobs. It has some example templates. It's almost identical to what we actually use internally. The utils are like basic stub utilities that I put in to illustrate how the job templates would work. So I put in some code for like writing to CSV and writing to SQL in here. I didn't fully finish the SQL one because the logistics around sharing database connections and stuff are difficult. So I did implement a CSV writer, and that's what I'll be using throughout this demo. This model is just some like very basic case classes for like some of the financial instruments we deal with, and is just meant to illustrate the key concept that we try and do all of our code in terms of our internal domain model. And then in this demo directory is just an example of how to literally create an application and run it off of this framework. And so before I go into any of the code I wrote before, I'm just going to kind of show you what it feels like to spin up a new one of these. So I have some object, and I'm going to extend an tow truck app. This thing takes a config that has to be a type of tow truck app config. I'm just going to go with a simple one that says I have one run mode. I also need to tell it some way to log, so I put in a console logger. And now if I look at what do I have to implement, all I have to do is get from command line arguments to the config that this thing can run. And so I'm not going to deal with multiple run modes or command line arguments. For this, I'm just going to say, you're always going to run the same config. And that's going to be a new tow truck run mode. And then these things need names, and so I'll call it live demo. And then the only thing I have to implement now is what jobs do I want to run. And so that's it. You can literally go run this. It's not going to be very interesting because I didn't give it any jobs. So it says it did nothing successfully. But that is like the basic way you get started. It tries to minimize the amount of code you need to write. So all you have to actually focus on are writing your particular ETL jobs. So now let's get to a job that actually does something. So for this example, basically what I want to do is take one CSV file of a portfolio name, a security name, a held position, and a desired position, and produce a new CSV file that's like a bit twisted. It's got now a portfolio ID, a security ID, a position type column, and a position. And so what that input file looks up. So that basically looks like this, the thing I uploaded. So basically, Apple and USA bond ISIN are going to be real securities. Random ID is going to be something it doesn't recognize. And I'm going to parse this, and I'm going to try and get to something that looks like this, where it's got IDs, and it's basically made it taller instead of a wide table. And so the way I'm going to write the code for that is I'm going to start with basically my modeled position. So I have a portfolio type, a security type, a position type, and my position as a number. And I'm going to get it to this position's output. And then one of the main principles we try and hold in writing these jobs is to not throw exceptions. Basically, just try and make sense of whatever you can and throw away whatever you can't. Don't presume like you know what data is important or not, because there's not actually any logic in here. We'll use like downstream gating checks or integrity checks to catch any problems with this process after it runs. And so you'll see a lot of options and maps and flat maps and tries and things within parsing this file. And so this is going to take a path to the source file, a way to write the output CSV, basically an implicit domain or like what data it's going to use along the way as it does this, and evidence that it can log this output to the CSV. And so I'm just going to start by reading in this file that I get passed. If I don't find 4 columns in it, I'll ignore the line, and otherwise I'll parse the line. And this is where, again, it's all using opts and tries. So if it can't turn the text into a number, it ignores it. If it can't find the existence of that portfolio name or that security name in our internal domain model, it ignores it. And for whatever it can do, it will give you back the format that you want. And so basically, the only things you have to write are this stage data, which is like how to get it to the modeled position, and then how to serialize it back to the like new raw position that you want to output it in. And just like we were concerned on the way in, we're also concerned on the way out about not failing. And so we're using opt methods everywhere. And so in this example, this would be like the concrete job in the vocabulary. The one CSV file write is like the job template that it is extending. And then if I look at how this gets plugged in, I'll see that in this demo app now, basically what I did is I set up a template to have multiple run modes. My parse args is pretty simple. It just says find one with the name that the command line gave and make a config out of it. And then this is just basically boilerplate set up to like pick some directories on my computer to point it to files, and I go ahead and instantiate it. And then one other basically optional method that a run mode provides is like a cleanup. So once you're finished running all of your jobs, you have the option to take some step that returns unit at the end. And so this one is just going to close my buffers, basically. And so this is a fairly representative example of what some of these apps will look like. So now I'm going to basically go from here into the like framework and things behind it that let me write this little code to actually do ETL jobs. So starting with what actually happens when I run the app. So it tells me basically I have to figure out how to get it a run mode, and then it knows how to run a given run mode. And so then you basically have the option of whether you want to run all of your jobs in parallel or not. And if you run it in parallel, you have to basically say how they should be grouped. we basically have cases, you can imagine a case where you might have multiple jobs writing to the same SQL table or something, and you don't want those running in parallel because you might get deadlocks. There might also be other reasons why you would choose to run them sequentially instead of in parallel. So it basically runs those, collects the results, passes the results to the cleanup function because you're not sure if you actually want to take post-processing steps if you had failures, or you might want to look at what failed to decide what to do in that case. And then it will print a report at the end. And this was a feature I added when our operations team that runs this asked me for documentation on what tables were updated every time they ran this thing. And so I said, I'm not going to write that down outside. I'm just going to make the code write that for you. And so this is how they go and see, like, if one of the jobs failed, it'll tell them what it failed to update, and then they can decide whether that's actually a big deal or not. And so then the main method is pretty simple. It just says try and parse the args, and if you get args, run it. Otherwise, exit. So that's the app. Then the framework is likely the most interesting part of this. So we basically say the config can be any type as long as it has a run mode. That's the only thing that the app cares about. But you might want to add more to your config to use it to instantiate all of your actual jobs, like pass in instead of me hard coding file paths on my computer, those might be some things you want to take from the command line. And then for a given run mode, in addition to the name and the jobs you want to run, basically the default is we mostly run things in parallel. And generally don't need to clean up, but you can override that and say what you want to do if you have to. And then here's the job itself trait. And so this is the thing that I said, this interface is not actually that like Typesafe or useful. It basically just says, tell me how to go from nothing to some iterable of a type, and then take that iterable of a type and do nothing with it. And so you could extend this directly, but generally that's not the way we do it. But one of the things that this does offer you, for example, is every job has a timeout on the extract. So nothing will just hang forever. There's like a default 15-minute you can set to whatever you want. It also will auto retry. So if anything does time out, it will just wait a little longer and try it again. And you can configure exactly how you want that behavior to work. I mentioned checking between the extract and the load. And so because we write everything to try and not throw errors and just ignore data it can't make sense of, if you end up with no data after you extract, generally it means something went pretty wrong. And so you don't want to try and touch your destination at all. You just cancel out and say fail out, like something broke in this job. And so then it basically goes and runs, and it does all of this like error handling resiliency for you. So it first does this get data with auto retry with the timeout. So you get like a future of a try of the actual extract. Then you log whatever happened there. And then you get a persistence result by just saying, if you actually had non-empty data, then go ahead and try to load it. Otherwise, skip that step. And then it will log what happens when it's finished. So the kind of last main useful things in here, or the most useful things are like the job templates themselves, which are the things that you want to extend directly. And in practice, these form like a pretty long like inheritance list of getting more and more specific as you go down. So here are just some pretty general like SQL and CSV utilities. This one happens to be tied to Squirrel as the ORM that we're using. So if we ever had another ORM, we'd have to abstract that one up one more level. And then the one SQL table write is the most common thing that we use internally. And this is where it introduces a little bit of type safety for you. So now what we've basically done is introduce two types, what I call a rich type, which should be your modeled data, and a raw type, which is what you're going to go load in your destination. And so the table is expecting the raw type. And so that's how you make sure that the table name you give this thing matches up with the type of data that you're going to try and put there. And then you end up just having to say how to construct your rich data and how to serialize it to your raw data. Generally, we also do like a wipe and load of our destination, but that is configurable as well. And then it can go and implement extract as serializing the stage data, and insert and implement load is inserting that table into inserting that data into a table. And then it handles that destination description so that the operations team knows what happened. And then the CSV file write pattern is actually very similar. You just basically replace the table here with evidence of like a CSV file and the schema that that CSV file expects. And you have the same stage data and serialized interface. And that is implementing extract and load and description for you. And so these are kind of like two of the examples that we use. And then most of the like internal development is on further like implementing these and starting to plug in things like the actual schema and database adapter to use, or like connecting to other types of data sources, and sometimes we will already have implemented the serialize for you. And so we have things that will extend CSV file write that takes serialization evidence, and then all you have to do is just say, here's my like modeled rich data, and you're done. Basically one other thing I'll talk about is if you look here, this isn't really like abstracted over how you're like loading from a CSV. So one of the things I didn't reset up here is like a library that will actually parse CSV files for you, which exists, and you can create adapters that would handle that functionality for you. And then the other kind of pattern that we tend to do is basically instead of, in this case, I have a dummy like entity repository where I just statically list a bunch of securities and their names and their identities, and that's fine for these purposes. In practice, that will all come from another database. And so generally what we'll do is have like one data cache of like primitive data that consolidates over all the input sources you might need to be pulling from. And then a bunch of these like repository traits that will then go take the like very primitive data from the source and model it and make sense of it. And we'll construct like one big concrete class that extends all of them and make each individual job only depend on like the specific traits that it actually needs. And so basically that was all the code behind this thing. The utilities are there, but not in any sort of state where I'd recommend using them in production. And then as I mentioned, the model was very simple. Like a portfolio was just a name. Securities are also basically just a name. And then this was like that repository that I was using before. And so, kind of to be explicit about some of the things that I didn't put in the demo, but we actually have for real with this thing. I just mentioned a little bit at the end, but the full pattern for abstracting over the input data, I kind of skipped writing for this, but I can talk to people more about if they're interested in it. Similarly, I didn't show like our full set of job templates. I just gave the CSV and SQL representative examples. And I couldn't really explain like how the testing would work in here. But we do use a combination of both in-code unit tests and integration tests. And that has helped provide some safety around this. So I have about 5 minutes for questions, or you can all hit lunch a little early. I'll pause for a minute and see if anyone has questions before we break.
Come back.
Hi. Could you talk a little bit why you chose an ORM instead of plain SQL, just out of curiosity?
Namely, because it was already there. And so we had already, basically the applications that ingest this data are all already like using Squirrel. And the interface actually works pretty nicely, specifically about the table of the same type as the rows to insert. And so I just didn't think about going to like recreate that work using raw SQL.
Does the application buffer all of the data incoming? And have you had any issues with that process?
So by buffer, do you mean like?
Is it holding everything in memory?
Yeah. So it does. So basically that, like when I was describing that data cache, that thing does, it's all lazily loaded. But yeah, if you're running like all the jobs and using everything in there, it will cache all of that until it's done. So far, right now, we've been running this with like 20 gigs of RAM and haven't been hitting any issues, but that could be a reason to either like split things into separate run modes and run them on different machines or something like that.
Any others?
Nice.
So I may have misunderstood what I was reading, but it looked like you're doing parsers, you're doing the parsing kind of by hand. Is there a reason you didn't use a combinator library for parsing and/or printing, or serialization, deserialization? Yeah.
So there's one thing where like I could have used like a better CSV parsing library, but then generally because this thing is like ETL and kind of just only side effecting by nature, I didn't really invest in any like kind of monadic combinator type types in this because instead it's pretty concrete in how it works, and so and there's not a lot of logic or things to really diagnose about it. So that was why I went with the approach I did.
Any others? All right. Thanks, Max.
Great. Thank you.